I'm CK. Tonight we're going to be starting a new project. Going to be making a do-it-yourself synth, build-it-yourself synth, the Elmyra 1.4 from Neutral Labs. I purchased the kit from Thonk, United Kingdom company. It got to me in like a day and a half from the UK to California. The shipping was amazing, very fast, very nice. I'll leave a link in the description. Looks like a fun synth. It's going to be not a chromatic type keyboard synth or melodic synth. This is a drone and a modification synth, so you can take other input and filter it through the drone or just have it as its own drone unit. So I'm looking forward to adding this to my studio. Let's see how it goes together. And let's see what comes in the kit. The faceplate, which is instructive in itself. Looks like knobs for time, feedback, mix, modulation, filter, volume, and then a power LED and a power switch. Then there are three, I'm going to say tone generators or drone generators. Each one has a shape and an envelope switch. As I look here on the picture, I'm not sure why they're switches. I'll have to figure that out. Then a tune knob, and these 6 touchpads. Then there are 2 more controls for scratch, which we'll figure out what that is. That's a knob. And bite, which is a switch. And bite and scratch are linked, so that makes sense. There's Elmyra, the name of the synth, and the logo for Neutral Labs. So that's the top thing in the box. Then the circuit board looks pretty straightforward, nothing too complicated. The density of holes is okay, and again, I'm always evaluating things like this for less experienced builders, and this one might be a little tough. Some of these spacings are pretty close, so a youngster may get frustrated by it, but in general the components are very far apart, so you've got lots of room to work with, and that's nice. And here are bags of components. Now the instructions are adamant. It's kind of cute. Big letters: do not empty any of the component bags now. The components are grouped into bags so all of them can be identified without having to look up resistor ring codes. Rather, leave everything inside the bags and take out what you need while soldering. Yeah, right, that's what we're going to do. No, we're not. We're going to look at everything, because it's more fun to look at everything first. I may not take it out of the bags, but I am definitely going to look at it. So here's a number of, here's a mini board that's got a number of surface mount components. That looks like a mini USB connector, and a couple of resistors, capacitors, a microcontroller, Atmel ATS-AMD21. I'm not familiar with that. It's got a little reset button on it. That's interesting, because I don't think this has any external accessibility, so that'll be fun to play with. And your standard edge connectors, I'm sure we'll be cutting those up and soldering them here and there as we go along. So that little mini board is kind of interesting. It's called Itsy Bitsy M0 Express. Oh, it's from Adafruit. I should look that up. I will look that up, and why don't I look it up right now? Because that's the beauty of... Let's go to Adafruit. Adafruit and Itsy Bitsy M0. Itsy Bitsy. If you're more familiar with this kind of stuff than I am, you may already know what this is. I will freely admit to not being all that up on all the Raspberry Pi stuff and ITZY and so on. It's $11.95, and it is something. Small, powerful, with Rockin Cortex M0 processor running at 48 megahertz. This microcontroller board is perfect when you want something very compact but still with a bunch of pins. Of course, it doesn't tell me what it does yet. It has 6 power pins. Okay, yeah, it does all these things. Oh, it's a little kind of... It's a Python driver. And it shows up as a small disk drive so you can edit it, and so it's just basically a little microcomputer basically on this. Okay, we'll figure out how that goes together once we see how it installs on the board. Then there's a bunch of knobs, which is always good. Two jacks, 1/4 inch standard mono jacks, connecting wire with no connector on that end, meaning I'm going to solder it to the board. It's powered by through a USB charger, so at 5 volts, 4.2, 5 volts, whatever you want to call it. And this little bag has got a bunch of resistors in it. Lists the resistors, capacitors, 4 LEDs, male headers, female header, 4-pin header, SMD. But yeah, there's nothing on the board that you're going to do, or I'm going to do, that is surface mount, which is good. Yeah, just your standard bag of resistors and capacitors and so on. This is a whole bunch of hardware. Panel switches, single pole double throw switches, washers, nuts, pots, LED sockets, and the touch plates, which will be interesting. I haven't worked with that particular thing before. And here, some diodes, more resistors, more LEDs. I don't know why they're in 2 different packages, but they are. And a wood case. This feels kind of like bamboo. In fact, I do believe it is bamboo. It's you might notice it's 2-layer, so it's braced internally. The panel will just go on top, and then there's a ledge, and it's got some interesting corner bracing. I'm not sure why they needed that. Maybe it was falling apart in their chests. Nothing on the sides, and the back panel is audio in, audio out. As I said this in the intro, this can act to modify other sounds, so that's where you'd plug in your mono signal in. It also has a power connector that's already connected. I'm not sure why they pre-installed that, but they did. So that's an overview of the parts. Now I'm going to get organized and see what we're going to do first. That's everything that comes in the kit, besides a sticker of the Neutral Labs logo. There's no physical instructions. That's all online, which is wonderful. So let me get organized for what we're going to do first. The first step, or first section, is to put, one other thing I forgot. There are some little rubber feet that are in the kit too. First is to mount the front panel controls. So I believe that's this bag, and even though they admonish you not to open the bags until you're told to, they don't ever actually tell you to open a bag, so they need revise their instructions there if they're going to be that adamant about it. But this looks like all the front panel stuff. Bunch of pots. These are those little touch pads, switches, and so on. Let me dig through and see what we're looking at here. Okay, first, place 4 LED sockets in position. Let me get my parts tweezers. Let me throw them around. It's 1, 2, 3, 4. Standard little LED sockets. It's interesting that the LED sockets are lined to the tune knob, so we'll see how that works out. And I don't have a little pair of pliers. Let me see if that'll... Yeah, that'll work. Okay, I've used these before. These are panel nut pliers to remove or tighten. They're very good. They're not typically blue. I've left the protective film on them to reduce scratching even more. But they're very handy for panel-mounted nuts on guitar amplifiers, on circuitry like this, and so on. And they're labeled ENP. That's capital E, capital N, capital P. And the only problem is I have no idea where I got them. So I can't tell you where I got them. But if you can find them, use them. They're very handy. One side of these tools is flat and the other side is got teeth to grip. So they work very well. And again, they don't scratch the panel. Better than getting a little crescent wrench or even a box end wrench of the right size. This is just nicer, and quite frankly I find that I don't over tighten panel nuts when I use this, where with a box end wrench I certainly can have a habit of over tightening. But on LED sockets on the front of a mini synth, you don't need 100 foot-pounds of torque. One other thing I'll notice or mention, because I didn't mention it when we went through the initial parts list, as you'll notice, there's no MIDI input, there's not even any control voltage CV input. So the touch pads are what's going to give it the input. So obviously it can't be directly sequenced or triggered by an external source, even though, as I say that, I'm thinking about ways to trigger the touch pads, and we'll figure that out once we get it all together. Now put in the 6 touch pads. You must use the plastic washers under the touch pads. Okay. So these are the touch pads. The little plastic washer underneath it, so they go there. And then put a nut on it. I'm assuming it's this nut. Again, the parts breakdown doesn't... Yeah, it's got to be that nut. And they also mention there is no washer. Because the nut must be in contact with the metal film. It looks like, I don't know if you can see this, probably not, but this panel itself has got circuit traces between everything. So all these, well, not between everything, but some of these silver circles, like the ones for the touch pads, have circuit traces. None of the other ones appear to, and all the touchpad circuit traces lead to this 4-conductor strip there. So that's interesting. So that means I'm not sure how much torque I want to apply to these nuts. Okay, now the next thing that we're supposed to do is find a part. We're looking for an SMD header, 4-pin SMD header, which again, if you're going to say don't open the bags, then you should indicate where things are. So the SMD header's in this bag somewhere. There it is. So we'll be mounting that right here, and I gotta figure out how to do that. It's gonna go to a, I believe it goes to the ribbon connector, so I'm not too worried about specific alignment or positioning up and down. Should be fine, and as they say, it's either a right angle kit or a flat one that they ship, so it's all the same. Now I gotta find a way to stabilize that. So I gotta go get something, so I'm gonna turn the camera off for a minute while I go find something. Okay, I zoomed the camera in a little bit closer, so I had to go grab a pair of locking tweezers, because that's what I'm going to use to keep the header in position while I solder it. So let me get it right in the right position. Again, I don't think it has to be completely precise because it's going to a ribbon cable, but I want it, and of course it just skittered away. Things do that if you're not careful. Just wait 1 second while I get the tweezers back in place. There we go. Okay, let me get some of my finer solder. I think I mentioned this in another video. I was watching somebody put a guitar amp together on YouTube the other day, and he needed some more solder, and he actually cut it with a pair of wire cutters. He had a soldering iron in his hand, and he cut solder with wire cutters. I don't understand that. So we're just gonna get these 4 pins. Oops. Okay, now at this point they say you're done with the front panel for right now, don't put in the rest of the knobs and so on. But I'm going to do something else. Again, they don't mention this, but because I survived through paranoia, I'm going to check connectivity from the pins to where they go on the traces, because again you can see the traces. So this trace goes to the far one, okay? That's got connectivity. The second pin goes to this one, and I got connectivity there. This pin goes to this, I think. Yep. Then this one goes to, oh, this one's common. Okay. So the soldering of the SMD connector worked fine. I've got connectivity and no particular resistance. So, but what that showed us is these three on the bottom have their own pins assigned to them. These three on the top are on a common rail. So that's interesting. So that's it for the front panel for right now. Now we're going to go into the PCB. Start with the two diodes. Now, in the instructions, there are notes on almost all the components except for resistors, except for most resistors. For example, these two diodes are the distortion diodes, and they also mention these are BAT 85s, but you could do BAT 54s. They're fine with that. And they also say regular diodes won't give the same edge. So they've obviously put a lot of thought and experimentation into this board, which is really neat. And any kit maker who encourages you to experiment or try different things is certainly a kit maker I want to probably do more kits from, depending on obviously how this sounds when we're all done. And they also have a little note in there, a column in there for those who may not be sure, who may not have done a lot of work about which components have polarities that matter and which don't. And of course, diodes, of course, have polarities that matter. And again, these are, so it'll be 1 mega ohm, and these are 5-band resistors. So that's brown, black, black, yellow, brown, for a very good tolerance. I mean, it's a tolerance of 1%, which I don't normally pay attention to resistor tolerances, since I'm usually building things with big, things like guitar amps where tolerance doesn't matter that much, but this goes to R1 and R15. So now a couple of 1K resistors. That's R2 and R17. Where's my garbage can? My garbage can is in the wrong place. Okay. Now for 47 ohm, not 47K or 4.7K, but 47 ohm. That's R3, R5, R7, and R9. And then for 4.7 ohms. And these are for the load resistors for the LEDs. And they mention in the notes, which is nice to know, you can substitute R18 for a lower value if you'd like the power LED to be brighter, or higher if you want it to be dimmer. And they say don't go below 50 ohm. So again, it's nice they've thought about people may want to change things, and they're going to give you their advice, and that's very handy. So R4, R6, R8, and R18. So R4. Now some 220 kilo ohm, 3 of them, R10, R11, R12, and the notes here say you could experiment with different resistor values for a different touchpad response. Don't go below 100K or above 1 meg ohm. So Later, after I've got this together and have been playing with it, I may go ahead and get my resistor substitution box out and tweak those and see how it feels, even though I'm not sure how I'm going to do that, but we'll figure that out. R10, R11, and R12. Okay, now some 10K resistors, and that's what I was confused about because there's 4 of them, and there was this 3 strip in one bag, and I was saying, where's the 4th? And the 4th one was in another bag, so bad layout there. R13, 14, 16, and 19. So that should be all the resistors. So, as we always like to do, let's see if there are any empty resistor holes on the board. All the resistors are accounted for. Good. Now I'm going to solder them up. Okay, so that's all the resistors and the diodes, and that'll be all for this evening. So you may see a different camera angle next time. Next, we'll put the IC socket on. And one leg's a little bent. Unbend that a little bit. Is it going to hold by its own tension? Yes, it will. I don't need to do anything to hold it in place. While I tack the first leg on. Double check everything is down. Everything's down. Finish it up. Okay, now we're going to do a couple of headers and the capacitors. This header will go here. Oops, I'm sorry. This header will go here. That's good. Now all the caps, except for the large ones. Okay, the next thing we're going to be doing is we're going to be putting a bunch of stuff on the itsy bitsy board. And I'm probably going to let me refocus because I've got to do this. Down here, we're going to populate all the pins on the itsy bitsy board with this, all the holes on the itsy bitsy board with this header And then we're going to put female connectors here to build it all up so it has a place to live. So let me refocus the camera down lower here. This is pretty straightforward. You just gotta lay it out right. I think I'm gonna do it this way again. The pins don't care where they are. Now what we're going to do now is take the female side, set that up. One problem when you're cutting up the female legs is you will lose a pin, so you have to be careful. Yep, I can barely see that, but that's okay. Okay, now we can mount that on the board. I'm not going to trim this up because I'm lazy. This may take a little convincing because some of the pins are a little cattywampus. There we go. All flat, all the pins are through evenly, so I'm gonna solder that Frankenstein contraption down. And that's that. That's probably going to be the most fiddly part of putting this synth together. Okay, now they also say at this point, take the Itsy Bitsy board back out, but I see no reason to do that. It's perfectly happy sitting there, and quite frankly, I don't need to be jerking the hodgepodge socket that we just built in and out. So we'll just move on with the Itsy Bitsy board in place. I'm going to put the X-Acto knife away. Now, next step is to place all the components on the front side. And that's all. That bag's empty. That bag's empty. Oh, by the way, the IC that goes in that socket is here. I just have not put it on the board yet. Okay, so we're going to do switches, potentiometers. Oh gosh, a lot of bent pins here. This is going to take a little dressing up to get right. I think they're all 10K pots. Yeah, they're all 10K pots. So that's easy enough. So put them all in the little holes. Polarity matters, but there's only one way to put these on the board anyway, so you can't mess it up too badly. Okay, there's one, and I'm just going to get the front panel for a second and lay it on top to see how that just looks to begin with. Oh yeah, dandy. Okay, there's all the pots, and I'm gonna again test fit the board just to see what the deal is. So, okay, that'll all work. Now, one thing that I didn't bother with here, these pots, of course, have an anti-spin tab on them, but it's so low, I don't think it's going to matter. I didn't want to break them off. They don't snap off like they do on bigger panel pots, like for a guitar amp, so I didn't want to mess with them. Okay, the next is to fit all the switches in. This is going to be a little more interesting just because there's nothing to hold them in. The pots at least had the centering lugs to hold them in. But these just kind of fit. Oh, that's why we got to take the itsy bitsy board back off, because this switch is behind the itsy bitsy board. So we'll deal with that right now, because I don't want to forget. So I'm going to take the switches back out, all of them, so again I don't forget, and pull the itsy board off. So the LEDs push up into those LED sockets, and that's going to be a little bit of a pain to get right, but it'll work out. Oh, well, I do want to pay attention to the colors. So the power is in blue, and then we got little orange LEDs for everything else. Okay, now we're going to wiggle everything in place on the panel. Now the pots are easy, but the switches are a little bit more of a pain because they're at an angle. But they were actually not much of a pain at all. So I was worried about something that didn't really happen. Good. Okay, I'm gonna get the board in two corners first. And solder those two pots real quick. All the switches are good, look aligned, switching well, not moving under my fingertips. So that's good. So now we'll go ahead and solder the pots. I don't know if you saw that, but I bridged a couple of pins on that pot, so. Okay, let's take a look. So that's all the componentry to be soldered on the board. It's all done, except putting in the IC there, putting the itsy bitsy board there, and then running wires to, I assume, from here to that junction. And now we can go ahead and put the nuts and washers on the controls. Don't want to go too tight on those because pull them off the board. And there we are. Except for putting the plastic knobs on. That's what we got. Let me go ahead and put the itsy bitsy board back on so I don't forget that. So that's the majority of the work done. We still got to go from here to here, put the IC in and some other, do some work on the main box. But we're pretty much done. Again, it went together pretty well. There's not much to it, as you can tell, because basically, since it's not a chromatic synth, it's not creating sounds. You don't have a bunch of VCOs or triggers or all the stuff that goes with that. This is just a drone box. So we'll see how it sounds probably tomorrow.